Alright, in this video, it's now time to begin putting some of the rendering code together for our new vertical renderer. Now, the way we're going to approach this renderer, since we've already got code that works very nicely for plotting notes in 2D space, we're going to base a lot of what we do inside of the vertical renderer off of the horizontal renderer. So we're going to be borrowing a lot of code, bringing it over, but we do need to do several changes to the things that we bring over in order to swap out the X and the Y axis. That's also going to include swapping out width and height on a lot of the variables that we end up using. But I just wanted to point that out, that rather than go by hand, start over from scratch, and re-engineer a lot of the 2D mechanics, we'll simply borrow from the horizontal renderer and change things as need be. So, in order to get started, we'll bring up our horizontal renderer, move things around a little bit here inside of our code view. Now let's begin. Actually, I'm going to move the vertical renderer all the way over to the left, and then next to that we have our horizontal renderer. Alright, the first thing we need to address are the fields that we'll be needing. Inside of the horizontal renderer, we can see that we have fields for describing the screen, the staff, and space inside of the staff. We're actually going to grab everything up until title positions. We're not going to worry about the background code when working with the vertical renderer. So, to make things very quick, we're just going to copy all these fields outright, jump over to our renderer vertical, and paste them in place. Now, looking at some of these fields and what their purposes are, of course we have things like staff height, which in the horizontal sense would measure the overall height of the staff itself. In our case, in the vertical renderer, we're not measuring the height of the staff track by track, we're measuring the width of the staff. Because the height is going to describe the entire playing field, the entire screen.
Right.
So that means in order for this field to be useful to us, we're going to call it staff width, because that way as we advance track by track, we'll advance from left to right. Now we also have span height, which was used to describe the space that fit inside the bounds of our staff, generally 1 pixel inside the beginning, 1 pixel inside the last track. But again, this is going to be measured in the x-axis, and therefore we're going to call it span width. Now to go along with span width, the space inside the overall staff, is broken up into individual tracks, and those also need to be broken up across X, and that means we'll measure the size of each track by measuring its width. So track height will become track width. Now note texture can stay exactly the same, note origin can stay exactly the same. Now note width, that was used so that we could position things centered, so that it would be easier to center things on notes and also center things like the hit line itself. Now, once again, we're not worried about width in the case of the note, we're actually worried about height. Because if you think about the note centering on things like the start line and various measure lines, we're going to need to center it in Y on those lines, since X is going to be described by the track. So rather than using the note's width throughout our code, we're going to be using the note's height. And therefore, we will call the field note height. And the final field, title positions, can remain exactly as it is. That's simply an array of vector 2's. Alright, now that we have some fields in place, the next thing we need to address is the renderer's initialization, which takes place inside of its constructor. So that means the next thing we'll do is we'll drop down the public constructor for our renderer vertical class. Inside of render vertical, we need to initialize all of our fields, and to do that, we're going to be doing a lot of operations that are almost identical to the horizontal renderer. So, once again, we will steal the code from note init down to titles and drop that into our constructor inside of the vertical renderer. Now, of course, we need to update a lot of the names to go along with the names that we currently have. For example, we don't have a note width field anymore, we have a note height field, and since that is indeed a height measurement, that means we need to look at the texture's height instead of its width. Also, when looking at the texture, even though the field is still called note texture, we need to look at a different texture from inside of style. We now need to be looking at style.note vertical texture. Alright, note origin, that calculation can remain the same because we're just finding the center point of the texture. Now down here inside of staff metrics, the first thing we need to record is a value placing the center of the screen. Now, in the horizontal render, we're placing that in the middle of the screen from left to right, or an X. So we're taking half of the width. Here we need to flip that. The center of our screen is now going to be between the top and the bottom. So we're going to be getting half of the height. Alright, now track height, that field is now called track width. And track width is going to be set to the value of note texture dot width. Staff height is now called staff width, and that is going to be equal to track width times the number of tracks that are currently in play. Finally, we have span height, which is now span width, and that is going to be set to staff width minus 1. Alright, that takes care of all of the naming and adjustments necessary to initialize all of our fields. So now it's time to turn our attention to some of the note positioning methods. Back over in the horizontal render, we have two methods that are used to position notes in accord with their tick and track values. Now these methods are getStaffPosition and getStaffY. And since getStaffPosition relies on getStaffY, we'll grab both of them, copy both of them together, and drop them in right before our draw method inside of the vertical renderer. Now, we do need to make some changes to these methods. In this case, we don't have need of a getStaffY value. The value in Y is going to be determined by the tick, not the position in Y. Also, the other function of getStaffY was to make sure that player 1 and player 2 got positioned appropriately on the screen.
Right.
And in the vertical render, player 1 is going to be on the left, and player 2 is going to be on the right. So the players are actually going to differ in X, not in Y. So we're going to take this whole method and rename it to getStaffX. And then the fields that it uses inside were for positioning things on the top or bottom of the screen. Here we need to change that to the left and right. So instead of looking at the height of the screen, we'll look at the width of the screen. So we'll change fixed drawing height to fixed drawing width. And we need to change that in 3 places. So everywhere we see fixed drawing height will become fixed drawing width. Now we're using the overall size of the staff to factor into this calculation, but here that is given as staff width instead of staff height. Alright, that should take care of getting the different staff locations set up. Now we need to look at getStaffPosition. The first thing we need to do is a very simple swap of X and Y. It's like we described on the whiteboard. Instead of notes being drawn and moving in X, they're going to be drawn and moving in Y. So that means we'll begin by simply swapping X and Y for our 2 variables, and I'll swap their positions as well. So X still comes before Y. And make sure that's a lowercase y to match the return. So now X is going to be describing the positions of our different tracks, while Y is going to be describing the position of the notes, either as being drawn and then later as they're being moved. So now in X we need to take into account things like the track width. Now as we're moving and positioning these notes, when we're taking the size of the note into account with this note origin, we also need to be looking at the X value of the note origin. And we'll be using the getStaffX method to figure out where the overall staff itself should be placed. Now when we're drawing things in Y, we need to remember that notes are going to be moving in the, when we're drawing notes, they're going to be drawing in the negative direction. So let's say we're starting at note 0, then we move on to a note that's 40 ticks ahead, it's actually going to appear 40 ticks higher on the screen. Now again, to get a location higher on the screen, we have to go negative. So in order to put that in place here inside of getStaffPosition, this is going to be represented by using negative tick instead of tick. So that way, as we progress forward, as tick increases, the outcoming pixel value will actually decrease, and that will cause subsequent notes to be drawn in the negative Y.
Okay.
Alright, now that we've got our positioning code adapted to the vertical render, let's begin drawing stuff. Let's take a look at drawing some notes. Over here in our render horizontal class, before we draw the notes themselves, we do have a few local variables that need to be handled inside of draw. So let's begin with the first three variables listed here in the renderer horizontal class. We have span Y, timescale, and scaled cursor. Let's grab all of these variables, drop them in place inside of the draw method, inside of the renderer vertical class. Now the timescale and scaled cursor values can remain exactly as they are. We just need to change the first value. We don't have need of a span Y. Instead, we would need a span X value. So in order to get across the staff, we're now moving an X. So we'll change this variable name to span X, and we need to rely on the getStaffX method to find the position of the staff, and then add the one additional offset pixel to deal with the placement of the lines, the starting and ending lines of our staff. All right, now we should be ready to move into some drawing code. The first thing that we'll draw using our vertical renderer is going to be some notes. So I'm going to jump to the renderer horizontal code so that we can steal the note drawing loop. So if you scroll down here near the bottom of the class, we have the section for drawing notes. So we'll copy that entire section, paste it in place, and now we should be ready to adjust just a few things. Almost everything here can remain the same because the idea of starting at the first note and going through subsequent notes remains exactly the same. The only key difference is in how we move the notes. Rather than panning them in X using scaled cursor, we need to pan them in Y, and instead of panning in a negative direction, we need to pan them in a positive direction. So that will be note position.y plus equals scaled cursor. Now, the other part, the positional dependent code, is the check that we're doing to make sure that the notes are on screen before we draw them. Where before we were, of course, checking the left side of the screen and seeing if the note had dropped off the left, or checking the right-hand side of the screen and seeing if the note was still off-screen to the right, and if so, skipping the draw call. Well, in this case, we still want to do the check, but we need to do the check across the y-axis. So we're going to change our note position in our first check to note position.y, and we're going to check and see if that is less than note height. Now, in the positive direction, we're going to check our note y direction once again. We need to check and see if it has gone off the bottom of the screen. We'll measure the bottom of the screen as being fixed drawing height plus our note height. Now, with all of this adjusted, we can see that there are no more errors in the code, and that should be all we need to do for the notes themselves. Now, at this point, we've got a lot of position resolution code put in place, and we've got some actual draw code, so let's jump into the game, test it out, and see how it's working so far. So let's begin by jumping into single player and bringing up a song. Now if we hit the tab key, we can see that we have notes that are progressing in the vertical direction.
Very nice.
Now as we're testing the code, it would be a lot more convenient to set up the game to default to using the vertical render. That way we don't always have to jump in and switch the key. So what I'm going to do while we're working on this renderer mode is actually jump in here and take the renderer vertical and move that so that it is created before the horizontal renderer, and therefore it will appear as the default one. One other small tweak I'm going to do while we're working on things is I'm going to disable the metronome sound just to make it a little bit easier to, well, as for lack of anything else, easier to concentrate as we're looking at the notes passing.
Don't like hearing that tick.
In this case, since we're not actually tapping out notes, it's
just annoying, so
yeah,
we're going to turn it off.
More annoying than helpful. So, metronome active here in config.xml will, for the time being, be set to false. Alright, with all of that, let's jump into the game real quick and just see what our testing environment currently looks like. If we jump into single player and jump into a song, now we can see the notes beginning almost off screen. Again, that's because of the lead-in taking into account. And then the notes progress off the bottom of the screen till the game ends, and then we're free to look at another song. I'll bring up the rock song since it progresses a little bit more slowly. But, I mean, so far everything is working very well. It's following the pattern we had drawn on the whiteboard. Notes progressing down the screen, so our motion is in positive Y, and if you look at the way the notes are plotting, if we jump over, actually it's, if I pause the game, that's going to, jump away from it. But just looking at the notes drawing, if we started at note 0, we would be drawing up the screen or a negative Y. So far, everything is working very well. Now, to move on from note drawing, the next thing we need to put on the screen is the visual tracks. So, in order to get track drawing in place, we will once again jump over to the renderer horizontal class, scroll up inside of the class until we get to the tracks section, and copy the track drawing code. Now, inside of renderer vertical, we'll jump in here just before the notes section inside of draw, and we'll paste the track drawing in place. Now, inside of tracks, again, tracks were drawn across the Y direction. So basically we were drawing vertical lines, and here we need to draw horizontal lines. So to begin with, I'm going to change the variables we use from note Y to note X. I'll do that by refactoring. So we'll hit F2 to rename, change note Y to note X, and then the same for track Y. We'll change this to track X. So track Y will rename, becomes track X, and that takes care of the variable names. Now we do need to make sure that the values we're storing in them are actually coming from X data. So when we run our get staff position call, we'll make sure that this returns the X component, and the same with our note origin. Now, once we've got these variables in place, we need to change the way our draw call is working. Since currently, if we look at the draw call and bring up our parameters, we can see that we have track X plugged into the Y parameter. So we want to change this around. We'll draw track X as the X parameter, and then 0 as our Y parameter. Since in this case, thinking about the tracks as they were drawn on the whiteboard, these tracks are vertical lines.
Right.
So that means we want to draw an X on the marker that they're supposed to be drawn at, starting at the very top of the screen, or 0, and ending at the very bottom of the screen. We also want to make sure that these are drawn with a width of 1 pixel. Now if we move over to width, we can see that currently the fixed drawing width is put in place. We would rather have a value of 1. So we'll draw up 1 into width, and that pushes our fixed drawing value into height, and we need to make sure that that value gets changed over to fixed drawing height. So in a nutshell, we've swapped X and Y and our width and height for the definition of this rectangle.
Okay.
Now, let's run and see how our tracks are looking. If we jump into a song, we can see that our notes are now nicely placed, centered on specific tracks. You'll also note, just like the horizontal renderer, the padding that we're getting is actually coming from the note graphic itself. That means that there are some transparent pixels padding out the left and right of these notes. That's why we can directly use the note width, yet get spacing in between the notes.
Okay.
So again, just like we had done in the horizontal renderer, we simplify the rendering code by applying the padding, simply using the graphic itself. But our note tracks do seem to be working very well. One last check we could do would be to go into free play and just make sure that all the notes across the board end up working. So starting with our cymbal, we can go down through all of our different drums, and we see that each drum lines up nicely on its specific track. Alright, now that we have tracks, let's also add in track titles. So once again, over to render horizontal. If we scroll down to the very bottom, the very last thing we do in the draw method is to draw the track titles. Let's copy that code out and go over into render vertical. At the very bottom, just after the note drawing loop, paste our track drawing code in place, and leaving everything as is, let's see what it currently looks like. Well, it does not line up at all. We're still drawing the track titles in the, I guess you could say, the horizontal sense. So we have all of our titles appearing in a line over on the left. What we want to do is we want to move all these titles down to the bottom. So that way we have the titles appearing at the side of the screen the notes move off of, and then we want to make sure that they center up on their specific track. So, in order to do that, we need to look back up to our track drawing code, since it's inside of the track drawing code that we record the position to use for the titles themselves. Excuse me. So what we need to do is we need to swap, beginning with, we need to swap X and Y for the locations of our notes. So for the time being, we'll take out the offset padding of 10 in X, and instead drop the value of note X minus text dimensions .x. And since we're dividing that by 2, that will allow us to center our text in X, placing it at the track position in Note-X. Now, to begin with a Y value, I'm going to drop this in as 0 just to begin with, so we can see where the code is positioning, and then we can apply the offsets as need be. So just swapping the X and Y gives us a scenario where we have all of our track names being drawn properly centered on their specific tracks, but they're drawing at the top of the screen, which gets in the way of our tempo indicator.
Those fit in there almost conveniently well.
Oh yeah,
It's almost like you had that planned in advance.
I know it does kind of come down to the text names of names that actually fit in the tracks, but
Right.
we'll leave that as a problem to whoever designs the names of said tracks. In our case, they're working just fine. All right, we do want to move them to the bottom of the screen now. And of course, simply moving to the bottom of the screen is easy. We look at global state, and we have the value of fixed drawing height. Now, we can't directly use fixed drawing height. If we try, we see that we have no visible names. What's happening is the text draws from the top left corner, and that means it's currently drawing off the bottom of the screen.
Just outside the screen range.
Now we can easily bring them back onto screen by subtracting the text's height. So we can take text dimensions dot y, subtract that from our fixed drawing height.
But now they'll be right against the bottom. Right?
That'll pull them on screen, but they're very close to the bottom of the screen. To put that little bit of padding back in place, we can subtract an additional 10 pixels, and then we should be ready to go. So now we have some offset space below the text names, and all the text centers up nicely on our staff.
Nice.
So that takes care of track titles. So our rendering code is well underway at this point. We now have music and the beginning of a staff drawn to the screen. We still have to address things such as the measure and beat lines. But we're actually going to divide the video at this point since there are a few topics to cover in addition to the rendering code. So we'll split everything right here just to keep everything nice and clean.
All right.
So that's going to take care of this video.